Hey everyone, and welcome to section 9.5 about applications of quadratic equations. We're going to break this up into two videos just because it makes it a little bit easier to digest the different kinds of problems. All right, so first up we have ourselves kind of numerical example here. And so we have that the product of two consecutive integers is 42. We want to know what the integers are. Okay. So if you remember from some previous applications, consecutive means that they're coming one after the other. So 2 and 3 are consecutive, 5 and 6, -10 and -9 are consecutive, and so, we're looking for a pair of numbers like that. Well, what I'm going to do then is name the quantity that I'm looking for. So we're going to let x represent the first integer. We could name the second integer something else, but since we know that they're consecutive, the second integer is going to be represented by x plus 1. All right, now what do we know? We know that their product is 42. So let's take x times x plus 1, and we know that that is equal to 42. And now we have a regular vanilla looking quadratic equation. So I'm going to distribute here and kind of solve like normal. All right, we get two answers, but those are not the two integers being referred to in the problem statement, right? The problem is looking for two consecutive integers. So there's two possibilities, namely -7 and -7 plus 1, or -7 and -6. Or we could also look at 6 and 6 plus 1, which is 6 and 7. And if you notice, both of those pairs of numbers multiply to give you 42, and they're both consecutive. So that's all set. All right, next up we have an architect designing the entryway of a restaurant, and she wants to put a big triangular window above the doorway. Now, she wants it to be as big as possible, but she is restricted from having the window have an area larger than 120 square feet because science reasons. So what she's going to do is say, all right, the area is 120 square feet. I want to know what the dimensions of the triangle are then. She also wants the base to be wide compared to the height. She wants to be 4 feet more than twice the height. So we want to know the base and the height of the window. Okay, here's a diagram. So that's what the window might look like. We want to know the base and the height of the triangle. All right, well, I'm going to need to name one of those. So let's let h represent the height of the triangle. All right, again, I could name the base another letter like B, but I already know that the base is defined in terms of the height, because it has to be 4 feet more than twice the height. So the base is going to be represented by the quantity 2 times the height plus another 4 feet. Now I want to keep in mind that the area is equal to 1/2 times the base length times the height length. So I'm going to be taking h times 2h plus 4, and I'm multiplying that by 1/2. So that would be the area of that window, and I know that it's going to be equal to 120 square feet. And Now we just solve. I'm going to treat that 1/2 h like it's one term, and I'm just going to distribute it. Alright, so since I'm tired, I'm just going to use the quadratic formula. That way I don't have to think about things that multiply to give me 120. So off to the side here, I'll do that. And we would get that h is equal to -2 plus or minus the square root of 484, which is 22, over 2. Now, there's two values for h that we're getting, but one of them doesn't make any sense because one of them is going to be negative. So we really just want the positive value. All right, so that means that the height is 10 feet. And since the base is 4 more than 2 times the height, we're going to take 2 times 10 plus 4. We get 24. So the base is 24 feet. So you can go through and check that, and our sentence would be something like, the architect should make the window have a base of 24 feet and a height of 10 feet. And yeah, that's it for this video. Next up, we're going to look at an application involving the Pythagorean theorem, which is going to be kind of an exciting thing. So stay tuned.